Alright, so we're going to look at polynomials in this section. So, firstly we need to start off with what polynomials are. Polynomials are expressions where each term contains only positive whole number integers. So what that means is we need to check the powers on all the different terms and check if they're positive. So the first one is going to be a polynomial because the power on the top is a 2, that's a 1, and that's x to the power 0. Okay? So that way we can tell it's a polynomial. Second one is not a polynomial because square root of x is really x to the power half. If you have anything divided by x or 1 on x, that's not a polynomial. If you write out your power, it's going to be negative. And then it's obviously negative as well. Polynomials where the highest power has a coefficient of 1 is called monic. So what that means is you check the highest power term here, and if it has a coefficient of 1, so this first one uses x to the power 5, so that'll be monic. It'll be non-monic otherwise, so if you check the second one, there's a 3 here, so that'll be non-monic. Alright, so there's 3 parts of the polynomial. The degree of the polynomial is going to be the highest power. So in this case, this one will be a 5. The constant term is where it's just a number. So constant term is this one, which is just a 5. Oh, what? Oh, sorry. Constant term is here, which is a 2. And then the leading term is the highest one, and that's the whole term, not just the x to the power 5, but it's the whole thing. So that in this case it will be negative 3 and times x to the power 5. So function notation. So function notation is what dictates how a number behaves. Now, if you want the technical way of looking at it, what a function notation does is it maps any x values to some y value, So if you're looking at this graphically, what that means is you'll have x values here. I'll use a different color. Here, here, and here, and then it will put it up to some y values, like so. That's essentially what a function notation is. Now, all we really need to do, though, when you're given a function notation, is to sub in what you are given in the formula. So if it's f of 1, you sub in 1 into wherever you see x. And then if it says y, then you sub in y. If it says negative 2, you sub in 2, etc. So let's have a look at the example on the right. You have f of x equals to 2x squared minus 1. So then f of 3, we replace the x with 3. So then we have 2 times 3 squared minus 1, which then gives us 18 minus 1, which is 17. If it says y, then we just replace the x with a y instead, like so. If it says f of x minus h, again, you just replace the x with x minus h, like so. Alright, so identity of polynomials. What it's saying is simply this. You check the coefficients, and because each term has to match up with their powers, the coefficients must match up. Alright, let's have a look at the example. You have a, b, and c, so that x times x minus 7 is equivalent to a x minus 1 all squared plus b x minus 1 plus c. If you don't know what that is, that either means equivalent or congruent. all it really means is exactly the same. Alright, so what you need to do is simply expand all of them, and then you match up your powers. So x minus 7, expanding out gives us x squared minus 7x, a x minus 1 squared plus b x minus 1 plus c. We expand that, we would get a times x squared minus 2x plus 1 plus bx minus b plus c. And I'll expand the first bracket now. Okay, now we need to be matching powers and also terms. So one of the useful things to do is to actually group all the powers, all the constants with the same powers of x. So ax squared, there's only one x squared, so we just write a. If you have a look at the x's, so we have a negative 2a as a coefficient and also b. So we're going to group that together. So it's b minus 2a that are coefficients in front of x. Then the last bit we have a, negative b, and plus c. So then you have a minus b plus c. Now, why do we do that? We have to match the coefficients. So if you have a look at the x squared terms of both the top here and the bottom here, we can then just simply look at what's in front of an x squared. So then in front of an x squared we have an a for the polynomial on the right, for the polynomial on the left, the coefficient in front of x squared, which is here, is a 1. So that means a is going to be equal to 1. Once we've done that, then we can match up the coefficients in front of x. So we have b minus 2a equals to negative 7 by matching our other coefficients. Oh, using green is probably not a good idea. Let's use orange. So minus 7 and minus 7. That's right, minus 7 is equal to b minus 2a. Subbing your value of a, b minus 2, minus 7. So then b must be negative 5. And then we match your coefficients of just the constants. Remember, a constant is just a number, so we can just write 1s. So then we have a minus b plus c equals to 0. Because if you look on the first one, there's no constants. We know what a is, which is 1. We know what b is, which is a negative 5. And then we just find c. So then c is equal to negative 6. Alright, we can also use a cast to do this. Alright. So polynomials, what we can do, we can also add, subtract, multiply, divide, just like we normally do. So if it tells you 2p minus 3q, 2p of x minus 3q of x, just simply multiply the whole thing by 2 for p. So then we have 2, 3x cubed plus 4x squared plus 2x plus m minus 3 times 2x squared plus kx minus 5. Expand all of that and back to terms like we did before. And then factorize out our coefficients. Actually, that's just 2x squared. In front of our x's, we have 4 minus 3k. And then If we match the 1s, we have 2m plus 3. So then we know 4 minus 3k is equal to 5. 7k is negative 7. Then you have 2m plus 15 equals to negative 25. So it's negative 20. Okay, division of polynomials. Now there's two types. One is by inspection. So what you do with the inspection is you check how much of a divisor is in the dividend. It's easier if I just show it to you. So we have x plus 7 divided by x plus 5. What you do is you look at the bottom, you have an x plus 5. And what we want out of the first one is we want an x plus 5, because then we can divide it easily. So let's write x plus 5 in, because the coefficient in front of it, x plus 7, is only a 1. So whenever we divide it, we're going to have 1 x plus 5 in there anyway. Now x plus 5, adding something gives you a 7, which is 2. So then you just simply fill that in, so it's equivalent to the first line. Then you would just separate the fractions, like so. X plus 5 over x plus 5 is a 1, because it's the same, so it's 1 plus 2 over x plus 5. And that's how you divide it. You can do the same if there's a multiple in front of the x. So we have 3x's home, so we still need an x plus 2. So we simply write 3 times x plus 2. Now, 3 times 2 is 6. 6 plus something gives you negative 4. So then x is negative 10. Do the same thing, separate it. X plus 2 is cancel. So then we're 3 minus 10 over x plus 2. Alright, now we're going to talk about doing division of polynomials by long division. In order for you to do long division, you need to firstly understand, long division of polynomials, you firstly need to understand what long division is. So I have an example on the left here. Usually what you would do with short division, which is what you would have learned in year 7 and 8, is you would divide 5 into 26 here. Let's say it's a 5. You have a remainder of 1. And then 5 goes into 19 3 times. And then you're left with a 4. 5 into 46, you would say 9 times. And then there's a remainder of 1. What long division does is it shows all the intermediate steps in between that you're doing in your head that you don't probably think about. So we said 5 into 26, it goes 5 times. 5 times 5 is 25. We subtract it, then we're left with a 1. That's where this remainder 1 comes from, okay? And you would drag the next one down, and say 5 goes into 19, like you did with the short division. It's exactly the same, it just shows all the intermediate steps, like so. So, when we're doing division with polynomials, we're going to do the same thing. We have x minus 1, and then x squared plus 4x plus 1. Now, the main difference is you would look at the x's and match it up. So x goes into x squared how many times? That's what you would think. If that's too complicated for you to think about, just write x squared divided by x, that out, and put it on the top. And then we multiply it like we did on the left here. So x times x minus 1 gives you x squared minus x, and then you subtract it. Be careful though, because we're subtracting the whole line, so make sure you put it in brackets. Then you have plus 4 minus x gives you plus x. And if you're confused, I might suggest you just write it straight in, like that. And then plus 4 plus x gives you 5x. And drag the next one down and do the same thing. You have 5x plus 1, so 5x divided by x, you have 5. So you multiply by 5. Then 5 times x minus 1 gives you 5x minus 5. Same thing, we're going to subtract it. And then 1 plus 5 gives you 6. So we have a remainder of 6. Now, although normally, we'll look on the left, we can write the long division as 269 divided by 5 gives us 539 and remainder of 1. But usually write it as a fraction, right? Like that, as your mixed number. We're going to do the same thing with the polynomial. So this will then be equal to x plus 5. Remember, we always write the what's called quotient plus the remainder on top of the divisor.